Hey guys,
Hey guys.
are you guys ready for a spooktacular Halloween?
Yeah, we're gonna decorate our haunted lab with a spooky, unusual decoration.
Look at this ghost over here. It doesn't seem like it's too much, but using a bit of chemistry magic, we're gonna make this glow an eerie blue color.
Blue. Ooh.
Let's get to it.
Creepy magic.
So, to make the solution, let's start off with 100 milliliters of 5% ammonia. This is also the typical concentration of household ammonia, but the exact concentration isn't really that important. As long as it's close enough to 5, it'll be fine. And to this, let's add 0.1 grams of luminol. The luminol is what will be producing the glow, and we're adding this so that we can get a glow. Let's also add 0.3 grams of Disodium EDTA. So let's let all that dissolve in the ammonia. Lastly, we need to add 10 milliliters of 3% hydrogen peroxide. So let's add that real fast. Okay, so now we have our ghost metal solution. All we have to do is let it dissolve. Okay, so now that our solution is complete, now we dilute it into 900 milliliters of water.
That is a lot of water.
Mm-hmm.
Why did you put so much water anyway?
It's how the instructions says.
Oh. Ow.
Okay, so now we have our evenly mixed solution that'll create the ghostly glow. So all we have to do now is pour out a small amount of it into this beaker. We need a source of copper metal. For our case, I'm going to use this penny right here. Okay, now when you drop it in, it's going to start to glow a ghostly blue color. So let's turn off the lights and look at the chemiluminescence. Ready, everybody?
Ready.
Dropping in 3, 2, 1. Ooh.
Creepy magic.
Check it out.
Check it out.
It's glowing.
Yeah, it glows. What's that foggy thing?
It's the copper ions diffusing away.
Oh. Can I ask you something?
What?
How does the penny glow?
Oh, it's not exactly the penny itself that's glowing. It's actually the solution around the penny that's glowing.
Oh. So the fog is getting the penny thingy out?
No, the penny is creating the fog nearby itself. It's not actually the penny itself that's glowing.
Oh.
Also, what happens is that the small amounts of copper dissolve away. So they form ions that stay near the copper. If you swirl it like this, it'll brighten up because copper ions will spread out into a solution. You know how they form the instant bright pulse as they swirl it. Interesting, isn't it?
Yeah.
Also very spooky. So that was the reaction with a penny. Did you guys like it?
Yeah.
Okay. This time, let's try something a little bigger. How about this copper wire shaped like a ghost? This ghost is already quite spooky. Let's see what happens if we dip it in the solution. Ready?
Ready. So what happened?
Well, let's go to the board. So, did you guys like it?
Yeah.
Was it scary?
Yeah. So what happened?
Well, let's go to the board and I'll show you.
To the board, Iron Man!
So the copper metal glowed like it was a ghost because of two major reactions, complexation and redox. So what happened first was that the copper metal first reacted with the hydrogen peroxide and ammonia. What happened was that the hydrogen peroxide first attacked the copper to form copper oxide, which then complexed with the ammonia to form a water-soluble copper-2 ammonia complex, which is like this. So it only works with copper and not any other metal. Now then what happened was that the luminol, more specifically its ammonium salt, since we dissolved it in ammonia, will get oxidized by the hydrogen peroxide into this compound and water. Now why didn't the reaction occur by itself then? Well, that's because the reaction by itself is way too slow. So we need something called a catalyst. A catalyst is just anything that speeds up a chemical reaction. For our case, the copper ammonia complex is the catalyst we need. So the copper ammonia complex will speed up the reaction of the luminol peroxide into these side products. Now you may wonder, why didn't diffusion just take all the copper ions away and then, just turn the whole thing blue? Well, that's another reason why we added the EDTA. You see, the EDTA has a tendency to form a complex with the copper 2+ ions. However, this new complex is unable to catalyze the oxidation of luminol. So, what happened was that this copper 2+ ion here just got cut off. So with no copper 2+ ion, the reaction cannot get catalyzed anymore, and therefore the reaction slows down a lot, making it negligible. And I may wonder, why did the solution around the copper glow then? Well, that's because so much copper was dissolving that it exceeded the concentration of the EDTA. So therefore, there's so much copper, the EDTA cannot consume them all. So the copper glows, but the nearby solution doesn't because all the EDTA will complex with the excess copper. So that was how the reaction worked. See you back at the lab. Bye! So that was how to make a very spooky Halloween decoration using some very easy to get materials. Thanks for watching.
And click the big thumb, the big bleedy thumb.
And the subscribe button.
Bye-bye. Meet you in our next Halloween video.